Let's say that we are the most important place in this infinite context where information can be found. In general, cosmologists all over the world are amazed by this constantly expanding exposure. City lights, which is 7 trillion miles away from Earth and hard to imagine, has become the center of the James Webb Space Telescope. To answer all of our questions, this amazing accomplishment does more than just broaden our understanding of the world. Experts are poring over the data, looking for clues that could help them figure out what these strange and amazing aids are all about. The ideas are strange because they make us think that we are following in the footsteps of some very special people in the universe, and that the universe is full of life and growth that is way beyond our control. Does it seem possible that these lights in the distance are from societies on other planets? What does this mean for our understanding of how likely it is that there is life in the world besides Earth? We are going to look at how the James Webb Telescope just saw the city lights from 7 trillion miles away. The James Webb Space Telescope was launched into space on Christmas Day 2021. Its goal was to take more amazingly clear pictures of new and interesting bright objects, planetary systems, and other things than the well-known Hubble telescope. One clear goal of the JWST is to figure out how the earliest worlds moved by looking at the faraway people who lived in nearby universes. It makes sense to do this since light takes billions of years to travel through our world. The JWST sees these things exactly as they were billions of years ago when it receives light. Light years are used to measure distances because that's how far light can move in a year. The mission's first big, workable idea was a huge field picture that U.S. President Joseph Biden showed off from the White House on July 11, 2022, to show how real this was. The Hubble Deep Field made a claim while the Hubble Space Telescope looked at the same part of the sky for 10 days in a row, starting on December 18, 1995. The area was very small. It took up only about 1/millionth of the sky. Hubble found 3,000 things that we can't see right now. Most of them were huge systems that were found billions of light years away. The JWST Deep Field also looks at a small part of the sky, but it focuses on the SMX 0723 galaxy group. The formation of the universe SMX 0723 is 4.6 billion light-years away. The galaxies farther away are pulled closer together by an extremely strong gravitational field. Where the gravitational field is strongest, the ground beneath the bright systems is bent into huge turns. In one case, it was proven that the light from a very faraway galaxy took 13.14 billion years to reach the camera. As we move through space, the light we give off gets longer as the universe gets bigger. The main goal of the JWST has been to turn visible light from stars into infrared light. Astronomers can easily tell the difference between JWST images and pictures of nearby galaxies taken by Hubble and other cameras. With that kind of data, we can see how galaxies have changed over very long periods of time and come together to form the shapes we see today. The speed with which the JWST took its first deep field picture, in just hours instead of days or even weeks for other telescopes, is even more surprising than the sheer number of objects it shows. It feels like it has to find galaxies everywhere it goes. A galaxy group isn't the only thing that can act as an amplifying focus point. Scientists use the JWST to take a picture of two worlds called VV1191, so they can study how the light from one of the two changed as it passed through the other. When this study is over, the features of how the intervening galaxies formed will be known. In addition, it looks like the JWST may have made a really cool find. The official JWST website said that light from a very faraway galaxy and the possibility of auroras on an exoplanet were seen. It is hard to tell where the energy in the high atmosphere is coming from because there isn't a host star and it is very cold. Anyway, it's very important that the object that is causing the aurora is actually giving off methane. The aurora borealis is a beautiful light show that happens when charged particles from the sun are caught by Earth's magnetic field. These charged particles then make their way through Earth's atmosphere and crash into gas particles near the poles, also causing an aurora. Because of the solar wind, the auroras on Jupiter and Saturn are similar. But the strange W1935 doesn't circle a star, so its auroras are a huge mystery. Everyone's doubts are still centered on Proxima Centauri, also known as TRAPPIST-1, which is about 4.4 light-years away from Earth in the Milky Way. Scientists have found evidence of water on the world, and it's not impossible that there is life there. Are we finally going to find proof that there is life beyond Earth? The JWST saw another incredibly huge black hole just last month. This huge black hole was seen at different frequencies, and everything around it is being eaten up by it. What does this mean for us? This find is 40 million times bigger than the Sun. The JWST found that this very big black hole has been there since the start of time and most likely isn't moving. Everything around this monster is being eaten very quickly. Dr. Lucas Fu and Professor Alastair Z from Israel's Ben Gurion University of the Negev made the finding. They found that the supermassive black hole is almost 30 times heavier than the Sun, which makes it a very big thing. It is found 129 billion light-years away from Earth, which is good news. The redshift shows that the black hole is eating everything around it very quickly, so it is still getting closer. Scientists were thrilled when the JWST started sending back its secret data. They looked through the data that came in for the program that was made public. They were interested in 3 small things that had a faint red flash. They quickly thought it was a huge black hole nearby. But when they used gravitational lensing to look at the data, they found something even more interesting. Similar things were happening in other early universe giant black holes. This has given us new information about how the black hole and the galaxy that it lives in have changed over time and how they are connected. This is still mostly a mystery, but it might be shown to be the early stages of development of massive objects like materials for making stars that fell into black holes. Scientists in space still can't figure out exactly what is going on in the pictures that are sent back to Earth, but one thing is clear. The James Webb Space Telescope finds new strange things every day. We love exploring space and being amazed by the beautiful lights of stars and planets that move through the universe light years away. Not only does the JWST let us see a lot more than our eyes can, but it has also shown us a strange object in one shot. This picture, which was meant to show something else, was taken by the European Space Agency while they watched 2 young stars grow about 1.47 light-years away from Earth. There is, however, a small orange mark at the bottom of the shot that looks like a question mark. It's clear that this small picture is not unimportant. In fact, it's very big. The shape of the question mark was caught while looking at how young stars called Herbig-Haro objects are arranged. These stars are surrounded by thick rings of gas and dust. As for the form of the question mark, it's possible that it looks this way from its own point of view because Webb only showed a 2-dimensional picture of it. We don't know what it is yet, and we might never find out if we don't do more research. Researchers have confirmed that what was found is, in fact, a structure far away, or maybe galaxies interacting with each other. The messed up form of the question mark might be the result of their work together. With all the far-off, exaggerated structures that Webb has found, there are always new, unexpected problems. Everyone is looking at a group of planets about the size of Earth that might hold the key to finding life on other worlds. The never-ending problem, which includes the fact that there is no proof of advanced alien life in the world, even though it is very likely that such beings exist, could finally be solved. In what place are these planets? To be exact, they are 40 light-years away from Earth. Also, the close group of stars is called TRAPPIST-1, and it has 7 planets circling it. NASA is looking at a lot of different factors in their search for planets where people could live. Instead of looking at a planet's size and distance from its star, it would be smarter to look at its atmosphere as a whole. This would help scientists figure out if the planet is livable. A long time ago, NASA's Spitzer Space Telescope, which looks at infrared light, found 7 harsh exoplanets circling the same star, TRAPPIST-1. An instrument called the James Webb Space Telescope has now found out how hot TRAPPIST-1b is. Since it was first launched, JWST has made many important finds. This is the most recent in a long line of record-breaking firsts. This is the first time that light from a world as small and cool as our own sun has been found. Other telescopes haven't been able to measure mid-infrared light that is so weak. When scientists first learned about the 7 TRAPPIST-1 exoplanets, they were very excited. All 7 of these faraway worlds are about the size of Earth and are in the habitable zone, which is the area where planets can have liquid water on their surfaces. But we can't reach the TRAPPIST-1 worlds right now, 235 trillion miles away, which is very far away. They go around an M-dwarf star, which is a star much smaller and redder than our sun. There are a lot more of these stars in the Milky Way than sun-like stars, which makes them great for planet watchers. But M-dwarfs are also more likely to explode and send out high-energy radiation, which could hurt any alien life that might be coming to Earth or the atmosphere of a planet. What we see when we look at TRAPPIST-1b is that it is locked to its star by tides. One side of the planet is always face the star, while the other side is always dark. The change in temperature makes things very rough. During the day, the side gets so hot that iron melts. The dark side stays much cooler, but it's still warm enough to stop the formation of methane, which is an important gas in the atmosphere. The JWST's ability to measure these extreme conditions gives us a new way to look at faraway exoplanets and their surroundings, even though it may make the planet less likely to have life.